Welcome to Vegas Programmers, I guess. Josh, your host, will be late. So I am subbing horrifically for Josh, but I'm sure all the stuff that he normally does at the beginning, he'll catch up in the end. So I'm Adam Englander, and I'm here talking about testing AI applications, a whole new ball game. If you don't know me, and most of you probably don't know me, I was one of the original people who started this group. Or restarted, I should say, 10 some years ago. I haven't been showing up a ton because one, I've been in Orlando, and two, I've been doing mostly Python for like the last 8 years. So that's a little bit about me, and now something about you. Just want to try and get like an understanding of what level people or what people do and how familiar you are with some of the things we're talking about, just to help me figure out where I need to spend more time and spend less. So anybody here do QA for production applications? Okay. I mean, does anybody not a QA person but have QA responsibilities? That often falls, like, if you don't have like an actual QA person, oftentimes you either QA somebody else's work or you're someone in management who does it. Okay. Anyone familiar with what unit tests are? Raise your hands. You know what unit test is? Write them regularly? Okay. There's not a ton of stuff about unit tests, but we'll talk about it a little bit. How many people are familiar with integration tests? And how many regularly write them? Okay. It's okay. Integration tests aren't that big a deal here. And then functional or feature tests? How many people know what they are? Okay, write them regularly? Okay. So, shifting of responsibility. That's why this presentation exists. So, to help kind of better understand what I mean by the shifting, let's talk about something that we'll probably be familiar with. Shifting ops responsibility, right? There's this thing called DevOps. There didn't used to be a thing called DevOps. Right? For a long time, good, it's reasonably readable. There were two separate silos. There was IT ops and there was dev. All right? And for most of my career, that's what it was. You were dev, you didn't mess with operating systems, you didn't mess with what version of PHP or Java or whatever's running on the servers. You just had code, and maybe you deployed it, and probably somebody else did. And you didn't really need to know a whole lot about it, but on the dev side, we did software integration testing. That's really all we did. Architects or lead devs might have done the interfacing, right? So when I was a lead developer, I would interface with the IT ops people, like, hey, we're looking at moving to this version. We need you to upgrade, need functionality, whatever. Or they would come to me about performance problems, right? But most of the devs never knew what it was running on, didn't care, because it didn't matter. And same thing with databases, right? You didn't mess with databases. There were DBAs. They were part of the ops group. And they would come yell at you about bad queries and just kind of make sure everything was up. You needed a new column. You ask them for a column, right? But now, I can remember what that was like, but I haven't done it in almost a decade, right? Because now there's this DevOps thing, which seemed like a great idea, right? So you remove a lot of the responsibility from the ops. The people on dev have more control over what's going on. And in theory, made it more agile, in theory. And then the problem being, though, right, is that it moved a lot of things over. But the ops people in kind of more modern houses, no slight if you're not one of these places, right? Most of the places I've worked at and most of the people that I know where they work, IT ops manage orchestration systems, right? They'll manage hardware, they'll manage Kubernetes or Swarm or whatever you're using, or whatever virtual server management platform. And then on the development side, we're responsible for the operating systems that they run in, right? Because everything's containers now. You may be responsible for the database, right? What version of the runtime, right? Configuration, right? What are the environment variables for set? What's installed as far as In the PHP world, you got to worry about extensions, right? In the Python world, not so much, but you might need core stuff. You never had to do performance testing before, but now you have to because you're responsible for the things that actually run. So it used to be a lot of performance testing was mainly a thing that was on the ops side, and now it's more on the dev side. Same thing with monitoring, and then you still have the software and integration testing. Right? There's good sides and bad sides. It provides more control for developers, right? There's one of the things I love about the new way to do development nowadays, right, is that there's no more it ran on my box, right? So I'm like, I don't know what your problem is. Look, it's running, it's perfect, it runs on production, that's your problem, right? And they couldn't figure it out, and you couldn't figure it out because you can't reproduce it. But again, it had a cost, right? There's all this stuff you got to know now, right? As a developer, you have to understand operating systems, at least to some extent, right? You have to be able to upgrade them. You have to be able to install packages that are necessary, where that used to be an ops problem, right? You got to understand databases, right? So you've got to understand configurations and performance testing and monitoring and all that type of stuff that you never had to worry about before. And because of that, like a lot of places, and even really big places, they're just moving that out of their own data centers, right? So now that you've got the DevOps stuff, the other stuff just lives somewhere else and it's somebody else's problem. So you may have people that are managing orchestration and stuff like that and setting up the networks and provisioning the instances, but they're not really managing the hardware so much anymore because that's platform as a service, whether it's on Amazon or Azure or Google, right? And the reason that I really bring this up is it adds a lot of, in small houses, right? I work at a small company. It's a whole lot easier to do complicated things because now as a developer, I know a little bit about operating systems. I know a little bit about, actually I know quite a bit about how to run Python. I had to. I used to be a DBA, so I'm really comfortable with the databases, configuration, performance tuning, monitoring. But now I can just deploy anything because I can use some DevOps tools, deploy it, and I can do whatever I want. Now, at some point, you get to a certain level where my limited expertise isn't going to take me where I need to go. But again, there's the plus side is that you can do so much more. You're not waiting on like, oh, hey, we're going to be doing this and it's going to need this package. And it takes ops a month to install it, right? It's like, no, it goes when it needs to be there. All the things you need are there. Things are running in containers. Life is good. And I think I saw most of you kind of shaking your head, right? The same thing's happening with data science, right? Models, AI, machine learning, deep learning, right? All the different words you want to call it. Those used to live with data science, right? So how many people here have worked at a company that had a data science person? Okay, good. So you know that there's these really smart people. Most of the places I've worked at, the majority of them had doctorate degrees that are really into data, and they are really into figuring out how to answer a single question, right? So if you're back in the machine learning world, right, it was a lot of give me a score, give me a risk score was a lot of stuff that I worked on, all right? And I want to know, is this person trying to commit fraud? Yes or no? How likely is that to happen? And you have these very smart people that have to know how to create input-output specifications, right? There's a lot of data goes into a model, and there's data that comes out, and they have to figure out what data they want going in, what questions can you ask, how's it going to give the response, design, what type of model you're going to use, right? Tuning, which is constant, right? I would say 90% of the time spent of the products that I've managed that were data science related, 90% of the time was tuning. Because your data changes, like this, we'll get more into that, but it's a whole thing, all right? And they have to performance test it to make sure it answers quickly enough, and they have to monitor it, right? And as a developer, all we had to do was use it, right? They give us the interface, right? Here's whether it's if it's local, running in a module, or you just know the API of the SDK, or it's on a remote server. It's just here's the input, here's the output. Pretty easy. Totally separated. But today, right, AI is moving closer to the developer, right? There's these things called large language models, and they're just an API away, right? You don't have to train them. You don't have to tune them. You don't have to design them. You don't have to performance test them. You can just use them. But there's still things you have to know to be able to do it, right? Even though, depending on how deep you get into it, you may not have to do data gathering, but you should, right? Because a lot of people just like, I'm going to make a prompt and I'm going to send it to the AI model, right? If you don't gather data to test if it's working properly, you don't know if it's working at all. And what you may learn is you need a lot of data to be able to see if it's working correctly. Fine tuning, right? So LLMs, if you're using some of the ones that are hosted by kind of standard stuff like Google or, well, Microsoft is still the same stuff as OpenAI, or I can't believe I want to forget their name, Anthropic, right? Those are kind of jack of all trade stuff where you can get more, if you find something like a Hugging Face where you can just host a particular model that's like an open source model that hasn't been tuned to anything more specific, that just knows how to talk, right? There's different levels of models that you can use. You may have to fine tune them. And you may find that you don't have to for quite some time, but what I've seen is that 80% of the stuff you need to do, you can do without fine tuning, and then you've got to fine tune to get the other 20%, and that is a lot of work. You have to performance test it, right? How well is your user of the prompt performing? Some questions take a long time, some questions don't take as long. And by the way, the models that you're using are probably going to return arbitrarily long responses, because you're just, the way that these things work is they stick you in a queue, and when there's a resource available, it'll answer your question and ship it back. So if it's getting slow, it may not be you. Monitoring. We have to monitor how well it's performing, right? And model usage. You have to watch how much you're using your model so you don't go broke. And like, these are some complex things that you have to learn to be able to use these things, right? But the ability to be able to do this, right? Your data science people are still on the left side, right? They're still doing all that stuff. They're making these things available to you. And there's a lot of power that's coming to you, like Josh's presentation last month, right? Here's how to use OpenAI. Here's how to do request augmented generation. If you're doing that, right, there's a lot of power. The problem is that LLMs don't work like models that you're used to, right? They don't necessarily always give the same answer. And most people are familiar with models as a service, right? It's the same thing as platform as a service, right? You can host your own models. I don't suggest you do it because it's really expensive and it's not worth it. From what I can tell, everybody else is losing a lot of money so that you can actually use these things. Because if you've ever tried to figure out, because early in the, I don't know, what, almost 2 years ago, we're like, hey, nobody's hosting these models, an easy way to consume them. Let's do that. Let's turn this into a business. And then we found out, well, we can't get any GPUs or any TPUs to be able to do that. And if we could, we couldn't afford it because we'd have to be constantly being used 100% of the time to be able to almost break even. So you definitely want to use what's going on there. Again, you may not need fine tuning, right? Like I said, but you're going to have to be able to figure a lot of that out, right? And then there's vector stores. So when you get away from the models, you get into vector stores. So when we're talking about request augmented generation, that's one of the ways that you can have a larger knowledge set for your application without having to fine tune the model. Right, so let's say a common thing for request augmented generation is like, I need a help bot for my website, right, or my company or my product. And you've got 600 pages of product documentation and 500 pages of FAQs. You can't send all of that to the model and ask it a question and have an answer from that. You also probably, fine tuning may make it better, may not. It's expensive. Every time you add something to the FAQ, you've got to retrain. Retraining is expensive. Every time you change your documentation, you then have to retrain. Probably not what you want to do. The common thing is to break it up into sizable pieces and put it into a vector store, and then use one of their algorithms to find usually k nearest neighbor and say, hey, I've got this question. Does this document have information? Like, what are the top 5 documents that I have in the store that are similar to what they're talking about? And then you just ship that along with your request to your model, and it comes back with a response. We're not going to really talk about that much. I just want to bring it up to say that, yes, it's part of a lot of AI applications, but the only time that this really changes is when you either change the model that you're using to determine what to get, or you change the data. Right? That's really kind of standard to anything. Right? If you're changing your code or you change your data, your tests have to change. And it's just kind of standard testing, so we're not really going to talk about it. And so the meat of this, right, is legacy versus AI testing. Right? Legacy testing is a non-AI environment, and there's a couple different things that are different for maybe unit testing, but it's mostly just in integration and feature testing. Unit testing, you have to determine specifics about how you want to test prompting, right? So if when you're testing units, right, that's unit testing. Legacy stuff, units are well defined. Inputs are usually small and well defined, right? You're not going to change your input a lot. You tend to change your code. But when you're talking about AI testing, right, what you're doing is you've got your application, and it's creating a completion message, and it's going to ship it off via the AI client to the AI and get a response back. Whether you're doing just straight HTTP or you've got a library or something, that's basically what you're doing. And that completion message is composed of a system prompt, which is creating guardrails for what your application is. How you want it. This is where you'll say, you are, for our example here, right? You are a product expert. You're answering questions about the product. You will not answer questions about the stock. You will not tell people whether things are good or bad, right? You're going to create all these guardrails about what you can and can't do, and give it context about what it's trying to do about the data you're going to give it, right? And you're going to be given information, questions from users, and then supporting documentation to provide that answer, right? The context is going to be the supporting documentation, right? And then, or other information about that particular type of call, and a user prompt, right? So the question. So you've got the guardrails, the context is the documentation you're sending along, and then a user prompt. And the system prompt, well, the context is pretty stable, right? I get a document from my RAG system, and I'm going to send to the client. So A in, A out, super easy. But the context changes because, again, it doesn't change a lot, but it's fairly static on how it does it. So it's actually fairly easy to figure out. But it's mostly the user prompt. User prompt, again, you're going to get something coming in from the user, and you're going to ask a question. You may massage a little bit, but it's the system prompt that's going to change constantly. When you are tuning your AI application, the guardrails around what they do is what you're going to change to make it more effective and more efficient, more accurate, right? You may modify the user prompt, but it's usually you want the user to just ask a question. And again, like all of this can be kind of, it's depending on how your application works. But the thing on the unit test side is to know that there are pieces that will be constantly changing and very large amounts of text. And you have to ask yourself, how much do I want to track that? And like, do I want to have a unit test that ensures that I send 65 paragraphs worth of words every time it goes? Or do I just want to make sure it got something, right? Because that's just a lot to manage. So on my applications, we don't worry about what the prompts are. We know that there's a prompt going. You'll find out very quickly when it doesn't work. because the something being different doesn't mean it doesn't work. It just means it's going to work a little bit differently, as opposed to kind of standard A plus B equals C type stuff. Which is, again, what we want to talk about. In AI, A plus B is kind of like C, right? An AI result, the answer may not come back in the same format every single time, right? If you ask an AI, what is 1 plus 1, always respond with a valid JSON response. All of those are valid JSON responses. Well, actually, number 3 is not. All right, that's not a valid JSON response, but it doesn't mean the AI is not going to forget to put in quotes. Depending on your model, a lot of the newer ones will absolutely return valid JSON because you can actually tell it to respond as JSON. But where is your result in there? It depends. Right? It's going to return you JSON. How it comes up with it, you could be very specific in telling it what to do. And it'll just do whatever it wants sometimes. All right? That is the beauty of LLMs, is that you can ask it all kinds of questions and it'll give you all kinds of answers. The bad part about it is sometimes it gives it to you as an integer, sometimes it's a string, sometimes as an object, sometimes as a sentence, and sometimes it just says it's a mathematical equation. It's completely correct, right? 1 plus 1 is a mathematical equation. So on the unit testing side, be prepared. Make sure that you have enough unit tests to cover what if it gives me crap. Am I going to just blow up with a 500 error? Or am I going to find some way to handle it and give a useful response or try again? Right? That's something in unit testing you have to make sure you're taking into consideration, because it will get crazy on the responses. At least in my experience. You never know what's coming back. And just trying to say, oh, well, it's going to come back as a 2 or a string of 2 and just convert it to an integer. Well, it can come up like words. Sometimes it's an object. Sometimes it's 1 level. Sometimes it's 7 levels. Who knows? So that's kind of the end of the unit testing stuff. Does anybody have any questions about unit testing stuff? If you have any questions while this is going on, this is a brand new talk and it is kind of disjointed. This is like the 3rd time I've run through it, and 2 times was talking to myself. Yes?
So when you're writing the context and you're trying to test the context, when you're writing your app, you're basically kind of curating, predetermining what context to put for that model to say always get an integer as a response when you want, or a sentence when you want, right? So right. That's part of what your unit test is testing, right?
So no, because like what your unit test is going to test is, did you say always return it as, so if we go back to, right, if I say always respond with a valid JSON response, right, your unit test is just going to test, but always goes back with a valid JSON response. Who knows what's going to come back? Right? Because LLMs will just sometimes just flip you the bird and move on, right? And they'll just return whatever they want to say, right? This is how I try to explain models to people. LLMs are like insufferable know-it-alls. Even if they don't know the answer, they will give you an answer and be very sure about it, and they will argue with you all day that it's correct, right? You can tell them, I want it this way, and they'll say, oh, I know better, you should get it that way, right? So again, they have a lot of power, but you have to be ready for the insufferable know-it-all doing whatever it wants. All right. So, like specifically in unit testing, what I say is like you're going to be constantly changing, right? So what you would do is, right, you'll be like, oh, I'll add another guardrail in here. Always return it as an integer, yeah, right? But sometimes it'll just say it's the integer 6, right? I returned it as an integer, and the answer is the integer is 6. So when you're writing unit tests, your context is going to constantly change, and just copying and pasting what you have in the code to the test isn't so helpful. All right? Sure, you can do it, and you can tell if somebody changed something, but you would probably know that from like a merge request, right? As opposed to, I have a unit test that tests a 7-paragraph block of code that has the guardrails. Not super helpful. But what you want to make sure that you're ready for is that you have unit tests around, when I return this, right, you create a mock and says, okay, cool, I call my API client and it's going to return something, all right? I need to be able to deal with the fact that it may not be valid, all right? So like you try and parse result 2, that's not valid JSON. Sometimes LLMs think that's valid JSON. It kind of looks like valid JSON, but it's not. Although JavaScript will accept that, it's not valid JSON. You have to have the strings. And then what happens when it's just nonsense, right? So just when you're writing unit tests for an application that's consuming an LLM, just make sure you're ready for anything to come back. And that you've got those bases covered. Any other questions about unit testing? Cool, because that should go super quick. So integration and functional testing. We won't call it feature anymore. Integration and functional tests have different places in the development lifecycle. They have the same caveats when testing. So we'll kind of deal with them together, right? How you would deal with one is the same as how you deal with the other. Because if you're seeing how this piece works with that piece, and if you're having to actually use the API for the AI, you've got the same problems. So one thing to remember in your tests is that AI requests cost money. In your development environment, remember that AI requests cost money, right? If you're like me and you've had a development environment where everything was local and you could do whatever you want and it would work just fine and it didn't cost you any money whether you ran one test or 1,000 tests, this is not the case when you're doing this, right? But there are ways to reduce costs, right? So fakes and mocks do not cost money. So if you have a system where you can specify which model client you're going to use and you use a fake model client, right, where all you care about is that I just get something back, I'm working on the front end UI, I don't care if the answer is right, I just need an answer, right? Consider using a fake or a mock to not have to spend that. If that's not something that you want to do, where you want to have the ability to just put in something that's going to return nonsense or the same answer every time, cheaper models is less money. So in our development environment, we want to make sure that it's working when we run tests. But in the development environment, we don't really care what the answer is because we're not doing performance testing, right? Well, I'll talk about that in a minute. Performance testing and feature testing are different, right? When you're doing functional testing, I'm testing that I got a response, right? Which is very different from how we've been used to testing, right? It's like you're going to test it. Oh, this field has this value because when I do this and I do that and I do that, I should see this, right? When you're dealing with AI, I should have an answer, right? Because how to evaluate if that answer is correct is a whole other world that we'll get into in a minute. So what we've done in our development environments, right? So we're OpenAI house. We use a bunch of their models. And so for development, we use GPT-4o Mini, the least expensive model that they have. Because it's right sometimes. It always comes back with an answer the same way as the Big Brother model does, that we use most of the time. It just, instead of costing us $1 a request, it costs us under a penny. So something to definitely think about, right? Even though you'd be like, well, I can't use the cheap models because I need the logic for my application. If you're running locally or you have something where you're just doing testing and no one's ever going to see the output and you don't want to actually take a look what the output is, make sure you make your system so you can choose different models and make it cheaper, right? We actually were forced to do this when we had a front-end developer come in. And they were just constantly like refresh, run on refresh, run on refresh, changing this, moving this here, moving that there, right? It's just like, bang, got charged $100. Bang, got charged $100. And I was like, whoa, we've got to fix this. So that's when we, because normally you don't want to be able to configure models. Because if you change your model, then you have a problem, right? You're going to get a different answer. And it may not even understand the question anymore. So we made configurable models just so we can, in the development environment, we can change it so that we don't run up $100 every 10 minutes for a front-end developer.
What about I heard also that data, using the same model, but just if you get more data to train it, to make the model better, that even costs money.
Training always costs money. It's a whole lot cheaper to fine-tune a model than to train a model straight out, but and again, if you're making your own models, training is really expensive because it still needs GPU. Using either Google or OpenAI or Anthropic, right? They have APIs for you to do that, and it's actually way cheaper than doing it on your own. But if you wanted to, figure out how to do all this stuff, there are places that can do that. And like I was saying before, right? When you're testing, you want to separate performance and functional tests, because again, A plus B kind of equals C, right? And one way to understand that, right, is if you go ask most models, why is the sky blue? All right, this is a pretty simple question, pretty simple prompt. The AI can respond with the same answer differently. And if you don't tell it not to answer differently, it will every time. All right, so there's an AI world, there's a thing called temperature. And if your temperature is non-zero, it will try and make it more interesting and give you a different worded answer every time. So it doesn't, like if I ask you a question, the answer is one way. If you ask it again, I'll respond a different way, right? So if you ask, when I asked OpenAI, why is the sky blue? It gave me two answers. The sky appears blue because of the phenomenon called Rayleigh scattering. And the sky appears blue because of Rayleigh scattering, which is the scattering of light by gases and particles in the Earth's atmosphere. Sometimes it'll mention nitrogen, the fact that the atmosphere is 98% nitrogen, and nitrogen is what makes it blue. Both of those are basically the same, right? They have almost all the same words in them, right? If you go with the first one versus the second one. So they share a lot, right? And determining the correctness of this result is very different from legacy testing, right? You can't just say like, it did say this, right? Because even if it doesn't mention the name of the scattering, right? If you're like, I care about the Rayleigh scattering, well, it could still be right, but not include those words, right? So you have to identify ways of grading the accuracy of output. And that is the hard part of testing the models, right? So how do you determine accuracy? This is one of the hardest parts as a product owner, a QA person, an engineer, right? Is that if you've ever had to have a conversation with someone about what they want, if you're one of those people that does that for a living, you've probably gotten really good at asking a lot of questions. Because people are terrible at telling you what they want. Like, oh, I want this, right? And they don't tell you why they want it, right? And then it comes like, oh, there's 100 other caveats. What should I do? I don't know. I don't understand what you're asking me. So you have to understand what they're doing. You have to get it into a much deeper level when you're talking about AI applications. Because you have to be able to identify what pieces are right and wrong, or what, and well, it's not even right or wrong anymore, right? How correct is it? And performance tests are going to think about accuracy in a different way, right? And so the majority of this talk is about performance testing, because everything else you probably already know, right? You know how to do feature tests and functional tests. You know how to do unit tests. And you may have done performance tests, right? Because performance tests are super easy, right? What you're used to is how long does a request take? How much CPU utilization does it have? How much memory utilization does it have? And how many concurrent requests can I have at one time? Right? So that's figuring out like how happy are my users? Because it's taking too long, and how long before I have to add another node or container or server or bump the CPU or memory in my servers or whatever it might be, right? The new performance test is accuracy. Because like I said, it can answer things in a different way. It can also just straight up lie, right? That's what a hallucination is. And it's not as cool as you might think. Anytime any part of the answer is wrong, it's a hallucination. It made up something that wasn't correct, right? So in testing AI applications, you have to be able to test how accurate you are. And it absolutely changes with AI in the mix. All right, so back to this, right, from the functional testing. So not only can two different asserts be correct if all you're worried about Rayleigh scattering, right? They can have all of that and be wrong, right? Because if it tells you that it's because of Smurf flatulence, right, it can have like looking for key terms, right? Doing all that doesn't work. because it can have all the things that you look for and still be wrong, right? Because all if you care about is, yep, I want it to be Rayleigh scattering. Well, that's an absolutely wrong thing, right? So if you're just like looking for keywords and trying to do nearest, right? I want to say like how, like one of the things that we did originally, right, is try to find, we were doing, because we didn't want to have to take the whole expense of getting something super complicated, and we were just using another model, local model, to say how similar are they? As long as they're 80% similar, they're correct. Oh, that just led to really false positives, right? Because again, that's 80% the same and completely wrong. And it really talks about smart flatulence, but in my experience, if you ask it something, in our application, when you ask it something that is not correct, so basically like the application I work with is for insurance adjusters, and it writes determination letters. And so it'll say, okay, what are you denying? Why are you denying it? And if the desk adjuster puts in an item that should not be denied, it can't find it, right? Because it shouldn't be denied. It is covered. And so it makes stuff up sometimes, right? If you ask it a question it can't answer, it is an insufferable know-it-all. Sometimes it will say, this is covered and here's why. But sometimes it will just say, this is not covered, and try and find things like to become like the most sleazeball possible insurance adjuster and try and piece together words that together sound like you're denied, but they came from different parts of the policy. So understanding when it's doing that, like it looks perfectly reasonable, right? It's just, and it's actually coming from the insurance policy. It's just not right. So it can be really insidious finding this stuff. And it also depends on what is your definition of correct, because that is an accurate statement, right? The ancient Greeks believed the sky is blue due to the divine nature representing the purity and calmness of the god Uranus. That is a 100% accurate answer, but may not be what you care about, right? So even if it's correct, that doesn't mean that it's accurate, because you have to define what is accurate for you. And so it really depends on two things, right? To determine how wrong they are. Because, right, when you're doing performance testing with an AI model, you want to figure out, like, how accurate is it? And so we have to figure out what are the restrictions, right? Because if the definition of correct is that it refers to the Rayleigh scattering, right? Then only two of them are going to be correct, right? It's 50%. But if you want the definition, right, if it's important to you, if you use a scientific term, you explain it, then only one of them is correct. And then if you only care if it's correct, right, so if you're doing like a support site for a product, if it gives you correct answers, it may not be the right one, but it might be helpful. And you're in a conversation with someone who can do something about that, then maybe that's okay. But if you're writing a legal document, which is telling someone what they are covering, what you're covering, what you're not covering as an insurance company, that's problematic. And again, how often is it wrong? Right? So how often does it actually give you a correct answer? Like, because if you ask it, again, if you ask it the same question, and even if you put in temperature 0, which is supposed to give the same answer, it comes back different. You ask the same question. Outside of the level of caching, you can ask the same question with the same information over and over and over and over again, and it will give you a different answer. Even though, in theory, it shouldn't. My experience is, it absolutely will. And my hypothesis is this is based on how these models work. So most of these models, you can tell them how many answers you want to give back and tell it the confidence level. And there you can also say like, oh, after this amount of time, stop looking for answers, just give me the highest one. So my assumption is that internally, they have a specific timeout, and that changes over time based on how long you've been waiting in the queue, right? There's a whole lot of things that go on with these things. So the models can't return different answers, but how you interact with the model can be different from time to time. Something to think about as well, that, and we'll talk about it in a little bit, is like you need to monitor this over time because the rules they create might be different and your answers might be different. So it can be problematic. So AI applications need to be tested before, during integration, when altering prompts or trying new models, right? Because performance tests allow the developers to determine if changes improve or degrade the application over time. Like one of the most frightening things, until you have like a battery of these, the most frightening thing is to change something, because who knows? Who's done prompt development at all, or just like ask AI stuff and see? Okay, so when you do prompt development, like just changing your putting a comma somewhere can completely change how it responds, right? You've just, I'm going to correct the grammar, and it was correct. I'm going to fix that. Nothing works, right? You want to fix one little thing over here. It's like, it's doing this sometime. I'm going to ask it to do something, and it's completely wrong from that point out, right? My experience with this stuff is like, you either like, I've had projects where it's frightening when it happens, but like you create a prompt, you think about it really hard, and you come up with it, and you really kind of do it before you actually test it. And you test it and it works every time, and it just goes to production and it works like gangbusters, and you're just deathly afraid because that never happens. Like 1 out of 1,000 times that might happen. But most of the time it gets kind of there, right? Like, I'm going to tweak this. Okay, no, that's better, but that's worse. All right, and do it again. Okay, well, that's better and that's worse. But that's just your real time, right? You have to do it over and over and over again because the answer changes depending on when you ask it. So there's a lot of testing that needs to go on, right? And any small change can have unintended consequences. The other thing to consider when you're doing AI applications is that model changes occur faster than you might assume initially, right? As a standard software developer, right, it's like, what version am I using? That's going to be static. That'll be there for, I'm using a long-term support version, so it's going to be supported for 6 years. Right? No model lives for 6 years. Right? They will just start jacking up the price because that one costs too much for them to run, and they want you on to the next model, and so it's gone. Or you have external pressure or internal pressure, right? Which is, hey, if you start doing AI development, hey, I heard about this new model. It's supposed to perform so much better than what we use. Why aren't we using that? You will get that a lot. And probably it is better. Right. So far, every time we've changed models, it has gotten twice as fast, exponentially better, and cost half as much. Until the most recent one, which is O1, which doesn't work great, costs a lot more, and is not faster. But you have to tweak your prompts to get them to work. That's one of the reasons you want to have the testing, is because even if you just move to another version of the model, it's been trained a little bit differently. It has new information. Your answers may not be the same. You've got to retest it. And that ends up happening a lot. Always pin your models, boys and girls. Don't just pin your software, pin your models. And again, like you have a lot of pressure because they always want the application to be better, cheaper, faster. So how do you test, right? That's the big question. And how you test will be very application specific, unfortunately, right? And you need to shift your thinking to properly test an AI application. Right? We talked about this a little bit, but think of rate of accuracy rather than pass or fail. All right? Using standard testing frameworks doesn't really work because standard testing frameworks are built around pass and fail. And models return different answers that are different amounts correct to the exact same question, right? So you're going to ask it a question, and who knows what's going to come back with. So again, it can be 100% correct one time and completely wrong the next. Request. And the more you run the test, the more likely you are to identify the real performance, right? So you have to run a performance test as many times as you can afford, right? Because again, tests cost money. Like on our application, one run costs about $1 to run one request. So we can't run tens of thousands, but we run all that we can afford. One of the things that you may want to do is identify which performance tests are more valuable, right? So whether that's customers care about this more, this might have legal implications, right? Whatever is identify, right? If you're doing product selection or you're selecting a library, you might create a little matrix that says, this is, these are the things I care about, and this is the most important, this is the next important, right? Do the same thing with your features and the things you're testing inside of your AI application, because you want to make the things, sure the important things are working. And it may, again, if they cost the same amount, you'll want to run the things that are important more and the things that aren't as important less, in order to optimize your evaluation. All right. And when you're testing, sometimes there's a Boolean evaluation, right? If you think of standard data science, right, there's the quadrant, true positive, true negative, false positive, false negative. AI doesn't work that way, right? Even the stuff that the data science folks used to use, because there is no 100% right answer. So you can get again, partial accuracy. But sometimes, I don't actually use any of these, but I know people that have, right? The response should be yes or no, right? That you want to know that, is this book about this, right? So I had, actually I did write one that had this. So basically I wrote an application that would go, you give it a bunch of companies and it would go crawl the web, do a Google search, find their web page, go through each one of the searches. Is this the company's website? Yes or no? All right. So you can test the Boolean stuff, but again, sometimes it's correct, sometimes it's wrong. So you want to do that over and over again to see how likely it is to be correct. And then figure out what you want to do based on how often it might be wrong. Right? If you ask it twice, does it always come back correct? Because it might differ with itself. Text similarity analysis, right? That's what I talked about earlier. Because again, Boolean is super easy, right? It's just, is it true or is it false? You may have to run it a few times, but you don't have to do any serious computational analysis. So text similarity analysis is computational analysis. You have a question? Okay. Where you're running a model and they're just available. I don't know what languages are available in. JavaScript, yes. Actually, PHP, yes. There's an extension that has it. I know that it is. Whether it will run, I don't even know. But they do have some model stuff, like old school model stuff in PHP. And this is really text similarities, old school. But again, we did use this, and now we really just use it for functional testing as opposed to performance testing, because we had it in performance testing and it wasn't very good at determining whether things were right or not. Yes, they're similar, right? But throw some Smurf farts in there and it's completely wrong. Model evaluation. So this is what I have been spending hours on, not just me, other engineers, is having models evaluate the results of models. Because models are the only thing smart enough to evaluate models. If you're lucky, you can use the same ones. If not, you may have to find others. We're still kind of in the process. This is time consuming, not only to develop, but to run. Models don't come back very quickly. And it needs to be evaluated over time, right? So you have to run them, because you have problems with you'll get randomly wrong answers back from the model. One thing we found we have better success with is what we were doing before is we were rating it 1 to 10. Tell me, grade this 1 to 10, and the models seem to deal better with sentiment. How do you agree that this is correct? 5 is absolutely, somewhat, neither agree nor disagree, right? Those things you're used to seeing on all the stuff everybody sends you to see how you like their things. I'm assuming there's just a lot of information like that out there that it had to consume, so they tend to be better at doing that. than a lot of other stuff. They're difficult and they take a lot of time, but it's the best way I know of to properly evaluate it. We hadn't thought about this until we went to an Open Data Science conference, and they're like, "Yep, this is the best way to do it." And we're like, "Well, we're going to try and avoid that." And then it was, well, you got to do it because we don't have a choice.
Is the model you use to evaluate the model response usually a smaller, cheaper model because
It depends. It depends on what it's evaluating. Sometimes we have a large context, right? So in insurance, right? If you're quoting, if you're citing a piece of a policy, you have to pass the policy to the model and say, is this language directly, concisely, exactly from this policy? The small models don't handle that well. Just like they don't handle finding stuff inside of it very well. It's just too much context. Yeah.
So what do you think about those companies like Annotate or Outlier that hire people to check the response from the model?
So, having people check the response from the model is actually human-aided, right? Is the best way to do it. The problem is, right?
But considering that everything is changing inside of the model, how optimal is this? I mean,
well, you're still going to have to do it on occasion because you're going to have to say because again, the model grading, how accurate is that over time, right? So it creates this whole other problem. So you're going to have a human in the middle to make sure that your tests aren't just completely off the rails. Like, oh yeah, this is amazing, but nobody's ever actually looking at the results, right? And they're like, oh wow, it says everything is Smurf farts, right? So. But the other model says that's perfect. So as your model that you're using can drift for your application, so can the model that's doing the testing. So it's you have to have a human in the middle, and it's not optimal and efficient. And you're not the idea, at least how we use it. Your usage and ability may vary, right? We are very concerned about litigation, about our results. So, and our customers are concerned about us creating litigation for them because they're insurance companies. The number one thing for our product is we reduce litigation because we don't quote the wrong language most of the time. We're more accurate than humans. But when we do it wrong and nobody catches it, then it looks bad on us. So the first question is that how complex of an evaluation is determines what model you use. Right? So like for our tests, and just like for our prompts, right? It's like, oh, this prompt we can do on a small model. It's accurate enough on the small model. It's cheap and fast, just do it. Right? This one requires a big model. This one requires breaking it up into 10 requests to a big model and then joining it back together in the end because it's too much for the big model. That's why our costs are so high per run. But that's, when you're trying to do complicated things through a model, you oftentimes can't do it in one go. There's just not enough context. It can't think about that much. It can't answer it well. But on the human side, right, one of the reasons we're adding this testing in is we ended up finding, so it was that piece about be careful what your examples are. Here's a tip from the trenches. If you give an example that is a correct answer sometimes, then your answer will always be wrong for that question. Because no matter how much information it has, if you've said question, answer, and someone asks that question, that will always be the answer. Because it goes, oh, I don't even have to go look. You told me what the answer is. I believe you. You're smart. And ours were more of examples, right? But we gave it actual examples. So we found out that, oh, everything looks perfect. This is correct information, except it's for the wrong policy. So identifying that and testing all the changes to make it better, right? To evaluate a single letter that we generate takes 10 minutes. It takes me 10 minutes, and I know everything about it. And it takes me 10 minutes to grade one. So that's why we went to model evaluation, because it's complex enough that it takes me, a human, 10 minutes. A human who knows everything about the product, everything about exactly what it's supposed to do. Because having other humans grade it we got differing results. Because they think, well, this is fine, and that's not fine, when in fact there are very strict instructions on how to grade it, and the humans didn't pay attention to the instructions. Because they were knowledgeable in the field and had experience and just used their experience instead of what was specifically said on there. So they're similar to models, I guess. So AI doesn't replace humans, right? The product that they build doesn't replace humans. It helps humans, but they've got to evaluate, like, is this thing make this up, right? Licensed individuals are going, this isn't right. And QA people are going, this answer is wrong. Even though it said it was good, it was wrong. We've got a problem with the test. Let's figure it out. Which is what I've been doing for a week, is figuring out why it's wrong, why the test evaluation is wrong. But the important thing here, though, is understanding what is right. So I talked about a little bit earlier, what does right mean, right? Because for the thing I do, right, the product that I manage and I design all the specifications for, there are 36 things it has to evaluate. And certain things are more important than others. Number one, most important, is don't do anything that's illegal, right? Don't quote something that's legal text. It's not actually legal text. Like, number one, always quote from the policy. If it's not quoted from the policy, the whole thing is trash. Beyond that, a few other things, right? Like, and so understanding what's, how to identify the level of accuracy, right? Because you may so one of the things we use this lovely thing, great word I didn't know existed until recently. It's called a dinkus, right? A dinkus is 3 asterisks. So it's similar to an ellipsis, which separates separates text from the same section of a document. A dinkus tells you, I'm starting a new idea. I'm starting a whole new section. And it's used in writing insurance stuff where it's like, oh, let's talk about this item I'm denying. I'm going to talk about it, and I'm going to put in a dinkus saying, now I'm talking about the next one, right? And for whatever reason, the models are pretty decent at putting them in. They're terrible at grading them. Because it's not supposed to be there, and there's not one. It doesn't need to be there. Well, but it does need to be there, right? So the grades aren't great, but our customers don't care as much, right? Pretty easy to figure out where dinkus is supposed to go. Same thing with ellipsis. If I see A2D4 and I'm missing some ellipses, I know to put them in. So if that stuff is wrong, not that big a deal. If it's formatted incorrectly, right, I can tab, right? I can hit the tab button and just move it over a little bit if it needs to move over. But if it creates text that looks like it came out of a policy, and I don't notice it didn't, then that's a huge problem. So it takes a lot of thinking to figure out what makes your output from your AI correct and how you want to test it. Because as we talked about earlier, right, little changes to fix one thing can have unintended consequences on something else. And so having a weighted scoring system allows you to say that, let's say if all your tests are all tests being accurate, let's say if you're doing it manually even, all right, if I do something that increases something that is important, like now it always cites text out of the policy, but every now and then it leaves out, it's getting worse at adding in ellipses, well, I'll absolutely release that live, right? So understanding what's important and being able to make either you as a developer, I've been in situations where it's like, I don't know, do you think it's good? Like the business people are just like, push whatever works. And then so they can yell at you later because they can say it wasn't their fault. Or you can bring an intelligent conversation to whoever your stakeholder is, right? So we've got the change that you asked for. Here's what it does. It does great things with this, but there's a negative happening over here. You still want to push it live, right? Because it's in the world of AI apps, that just happens. You have to make those calls because sometimes you get really lucky, and you can make the thing you want to make better, and nothing gets worse. But that's rare, especially when you've got it pretty dialed in. So this is like the type of weighted scoring thing that we do, similar to what we use, right? Is you identify the items that you care about, the weighting, and then the instructions on how to score it. One thing I have learned is that you want the scoring instructions. If let's say you brought an intern off the street who knew nothing about your product, who knew nothing about the industry that you were in, but they could read and write at a college level, that is an AI LLM. So you have to be very explicit. If you have to be very explicit with an intern on how to do something, you need to be just as explicit with the instructions. Whether you're building a prompt or whether you're testing it, it's the same thing. It's very good at understanding. It can understand language and respond at a college level, but it doesn't know. It's unless you're using some sort of industry-specific model, and there aren't a ton of those. It's not going to understand what you want unless you tell it exactly what you want. So again, like for ours, it needs to be accurate, it needs to be understandable. The responses need to be relevant, because you'll ask it like, why is the sky blue? Dolphins hate rain, right? It'll just do stuff like that. So identify like how relevant things are. Does its response read and flow well? Most of my results are like it's always really good at grammar. That's one of the few things that they're really, really, really good at, is responding in complete sentences that have proper grammar. We talked about the weighting. We did that. See, I'm actually getting over my time. So, and again, like the scoring instructions, those are very, very basic, right? But they turn into your prompts. If a human can figure it out, so can the AI. And then accuracy over time. So this is there's some stuff we've talked about with LLMs. They just kind of like, they're different from time to time. But then there's something that data science has been dealing with for a long time, right? And that's that the accuracy of the results from your model can change with or without any change to the model or prompts. And there's a few reasons for that. So let's not talk about model drift, because models sometimes just do different things. With the same model version and the same prompts, it can change because sometimes your user input is changing. If you think about it, some of that can be like let's say you're adding more, you're all US users, and now you're adding people in Canada, right? And they talk about toques, not beanies, right? So they have different ways to express the same thing. So you're really good at talking about your beanie products, right? But someone asks you about a toque and you have no idea what they're talking about. So external forces like that can happen, right? So you can think more about, if you get outside lift versus elevator, boot versus trunk, right? There are words to describe things that are different. And that your user base can change in how it is. People are older, people are younger, right? If your user base changes, the words they use to talk to your AI will be different. And then over time, the exact same user base can change what words they use, right? I don't think 10 years ago I ever used the term DM, right? Nobody talks about texting anymore. They just DM you, right? And so if your model doesn't know about DMs, it's going to be less accurate, right? If it doesn't know that DM and text mean the same thing. So your model didn't change, because unfortunately sometimes your models have to change because there's new language that people are talking about, or they're more likely to talk about. Or your prompts need to change to say like, oh, by the way, if you ask about this or this or this or this or this, right? You can help the AI understand the correlations between things that you're having difficulties with. And then if you're doing RAG, right, the data that's being used can change. So if we talked about it a little earlier, right? You don't have to test RAG so much because it can change, but if your product data changes and your model doesn't understand it as well, or your prompt needs to be modified for that. you may have to make changes to the model. Right, and what we talked about a little bit, right? Even if none of that changes, if your users don't change, and the input doesn't change, and the data doesn't change, and the model doesn't change, sometimes they just change stuff in front of the model. All right? Does anybody hear about the time where OpenAI was returning just garbage for a day? It's because when you use their API, they're doing a really handy step for you, is they turn your text into tokens, or they turn into a vector that they can then send to this AI model, and it responds back with a vector, and it gives you and it changes that into text. And they changed the vectorization algorithm with a bug, and it was like, I think it was either shifted left or shifted right, and so it would translate into garbage. But again, it's just a word association thing. So it came back with a response, and then turned those into words again, and it was just garbage. Nothing on the model changed, right? You didn't change what model you were using. Nothing else changed, but all of a sudden the response is very different. So when they make little changes to that, they may change I'm going to change how long I'll wait for the model to respond before it times out, all right? It may have been going for 11 options, and the 11th option was the best one. Now they've changed it, and now it's the 10th option. The 10th option isn't as good, right? There's just stuff like that happens. So you're going to have to, even if you don't roll stuff out, you still have to run tests. You still have to run tests. You still have to run tests. You still have to run tests, because the stuff will just change over time. And again, like I said before, you will change model versions, whether you want to or not. Inside pressure, outside pressure, you're going to change model versions. And the better you can do this, the better off you are, right? Sometimes you get stuck, and sometimes you're not, right? Like sometimes you go, I'm having a problem. Like one day, let's say all of your things fail because you're exceeding a limit that never existed before. And you've got to drastically change models very quickly, because now you can only have 10 images per minute instead of what you were doing was 12 images per request. That happened to me one day. Not a very good day. And so I had to change models. I had to see, does this still work? I had to find a model that still worked with the same level of accuracy. So I don't have as much experience with the Gemini models or the Anthropic models, but I have had OpenAI just all of a sudden, poof, here's a new thing that now none of your stuff works because you're exceeding limits that didn't exist yesterday. So be prepared for that. And switching to using Microsoft versions of OpenAI models don't help because they have lower restrictions. So random sampling, right? Do what data scientists do. When you're talking about testing over time, you want to track model accuracy and the value over time. And how you can do that is you can just, if you're using tracing systems, right, you don't send all the traces because it's too expensive. You just tell it, I want 1%, 5% of my traces so I can see what's going on and take a look at it. It's the same thing with your model testing, right? You want to just have them constantly being tested. All right, so we have a system called Critic that critiques all the responses, and it will just take whatever percentage you set for that customer, it'll just grade them. And you want to monitor it over time, and just like any other alerting, right, you want it to alert you when there's a problem, right? You decide on your own, this is what I care, either it's a total of all the scores, or whether it's this particular individual score can't get below this or change more than that on the way down over a period of time, right? Because what you may find is you have a dip, but it goes back up. So be careful on your alerting, because you may just spend a lot of time doing nothing. If you've ever seen that with servers, like, oh no, we've got 100% CPU utilization for half a second, and the whole country's been alerted because there was 100% CPU utilization, but it's gone now, and it was an anomaly, and it's not coming back, but now everybody's just freaked out about it. So same kind of thing there. So finally, so this is long, it went over. In summary, verify you're prepared for unexpected results in unit testing. right? The response can come back however the AI decides to return the response. Reduce development costs by using fakes and mocks where possible and cheaper models were not. All right, don't spend all of your budget on tests and development. Define accuracy and value in your application and create a testing scheme to evaluate both. All right, you want accuracy, but you also want to know how important that accuracy is, right? Split it up into pieces that are uniquely different, and then identify which one's more valuable than the others, so that you don't spend all of your time worrying about, like, if you think everything is the same, then everything goes up and down as you change things, right? So you just need to be able to make sure you can test that accurately so you can work with models. Validate the accuracy and value of every release, right? So before it goes out, hopefully you've done this, and after it goes out, hopefully you've done it. And then validate accuracy and value over time, all right? Because even if you're not deploying, let's say you're an industry that has, let's say, a holiday freeze, right? Because you're going to be getting a bunch of traffic. Well, you want to make sure that bunch of traffic isn't reacting poorly and having a bad experience. Or if you have an application that doesn't change a lot, you still want to make sure that your drift is not going in a bad way. Questions?
I got a question.
Yeah.
When you mentioned before that the first thing you care about, like, not do anything illegal, right?
Well, not do anything that's going to cause litigation.
And how does that know that?
So for the applications that I work with, right, is that when you're denying someone's, it's not that you're doing anything illegal, right? It's that you're going to lose in court. If you tell someone that you're not, say recently we got a hurricane, and you're claiming, like, say there was no damage to your roof, but you had some flooding, you didn't have flood insurance, everything's going to get denied, right? Because flood insurance is only covered by flood insurance. When you deny that, you need to cite the piece of policy that's their policy, right? You can't make it up. You can't use somebody else's policy, right? You've got to cite that exact text. So in our application, that is the number one thing, and actually its biggest selling point is because apparently humans just aren't great at it. Humans like to, because these things take time, humans cut corners, right? If you're an industrious person like me, you come up with a system to do the least amount of work possible to solve every job. And sometimes when you're in a rush, you don't think about, oh, I've got a letter, I just wrote one of these letters like this, I'll make some changes and it'll be fine, except it was a different policy, or they had a different endorsement that said, oh, this actually is covered. So again, on our application, there are very specific requirements that the citation text, and it's very obvious where the citation text is, must be verbatim, word for word from the policy. So you give it the policy, you give it the output, and you tell it to grade, here's how you identify the policy citation section, and verify that this is word for word, sentence for sentence, directly from the policy that I'm giving you. It's a lot more complicated of a prompt than that, but that's the gist of it. Because to get it to accurately do that is quite a bit of work.
You talked about a lot about, like, accuracy and thresholds and things like that, which
right.
70% or more. But are there a lot of situations where, because of you said, like, the legal and negative things, where, like, if it comes across anything that is negative, you just automatically fail the test? So, like, it might still be, say your threshold's like 75%, and it might be like 74% accurate based on all their criteria, but because it failed one, like, almost fail switch.
Right. Well, that's what, so on ours, right, if we go back to the rubric,
the 10,
right? Yeah, you changed 10 to 1,000.
Yeah.
Which is what we did.
Yeah.
right? So yeah, accuracy on ours is 1,000.
Yeah.
So you absolutely fail. Like, oh, if accuracy goes up a little bit, but something else goes down considerably, it's better.
Yeah.
All right, because that's the thing we're really, really concerned about. You may not have the same situation where it's like, well, this is twice as important, right? It's kind of like if you think of it as doing like a product evaluation. I have these requirements, and like this is more important than that. How much more important is it? Same thing when you're doing your grading, is how much more important is that particular functionality than the other functionality.
Right.
Right. So in this one, it's twice as important as relevancy and 3 times as important as grammar and just double accuracy. I just came up with random numbers for that. But like I said, on ours, the accuracy thing, it doesn't have to be in the right format. It doesn't have to have ellipses correctly. It doesn't have to be in the right hierarchy. It just has to be the right text. Because if you go to court and you're like, oh, this is not my policy, I'm taking this to court, right? Or I'm going to tell you I'm taking it to court, and they're just going to pay it out. Because they're like, oh, yep, we screwed that up. Yep. And so that creates problems where they have to resolve that. And if they do take it to court, they're likely to lose.
Yeah.
Because it looks like they lied. They just made it up. Yeah.
So you said that the response should be coming word by word from the policy.
Yeah.
Okay, but what if the words are the same, but the meaning is not the same?
So
How you test it?
So with the meaning is the same, that's relevancy. So like there's different criteria that we use for that. So again, like first of all, the meaning can be different. So sometimes, and it does it rarely, and it tends to do it when you've painted into a corner, like you've told it, I need you to tell me why I'm denying something that you shouldn't be denying. Right? So if there's something that's actually covered, but you're telling it to deny it, it'll be like, oh, well, if you want to deny this, if you took this sentence and that sentence and that sentence and that sentence, which are completely unrelated, and read them together, that's a perfectly reasonable reason to deny it. Right? So we do see that. And we call that a hierarchical problem, right? Because it didn't identify that, oh, these are different sections of the policy. So it's very obvious that if you were actually put in like the 2 sections and the subsections that those came from, that they weren't together and they weren't meant to be taken together. Then that becomes less problematic. Now, on our system, again, we don't replace humans, we augment humans, right? I like to call it augmented intelligence, because we're going to generate what we like to think of as a really good rough draft, and a licensed professional is going to review it and say, this is or is not what I want to actually use in my letter. And then their manager is going to also look it over and determine if they did it correctly. And if it, depending on the dollar amount, the director of claims may look at it, or the VP of claims may look at it, or the chief claims officer, right? So there's a lot of fail-safes in there. But in regarding to the testing, right, is we have criteria that we set up, and you have to, just like you said, we need to make sure that it can use all the same words, but it's not what you should be saying. Right, you have to have a way to identify that and let the model doing the grading understand how to figure that out, right? Because how we grade for that is a hierarchical problem, right? So that's our number 2 thing we care about, is hierarchy. Because if you don't display the hierarchy of the citations from the policy, it can look like it all goes together, right? Because you've got sentence, ellipses, sentence, ellipsis, sentence, right? These are all from different things. This one is like rights and responsibilities. You've got another one that's from exceptions. You've got another one from what we do cover, right? And they're talking about things that you do cover when trying to deny it. So in our particular system, right, that's our second most important thing, which is hierarchy, that you're including the full hierarchy so it's not deceptive.
So you try to predict all the possible questions coming from the customer and feed the model with them, and then review the response. Is it the way that works? I mean,
how we did this, right, is so we came up with a proof of concept, and it worked pretty good. It looked really good. It was like, yes, this is amazing. And then we started using it, and we were like, whoa, this is all made up. And we got better at that, and when we started actually getting customers, it was okay, now we have people who care, right? This is actually going to go out to a customer. It's going to go out to an insured for a hurricane, and started evaluating the product. I had to sit down with attorneys, right, at the insurance carriers. Like, okay, tell me what's legally correct. All right. So we want to make sure, first of all, we want to reduce litigation. So what are the most important things to you, like legally wise, right? And those were the ones, like, don't cite policy language that doesn't exist, because we get dinged for that. Don't rearrange policy language to make it sound like it should be denied when it's not denied. Don't quantify damages, because if the person who went out and looked at it, the field adjuster, says there were 5 shingles that were damaged, and there were 6 shingles that were damaged, or 20 shingles that were damaged, that's problematic, right? They're just like, well, there's these shingles, I saw 5, whatever, right? May not seem like a big deal, but to an attorney, it's a huge deal. So I had to speak with attorneys. We had to speak with the QA people. We had to speak with the claims, some of the senior claims management people, and just tell us how this needs to be. Tell us what's important. Tell us how to understand, because we're software developers. Like 2 years ago, I was doing cryptocurrency apps. Now I'm writing AI apps for insurance. I don't know anything about insurance. So I had to get deep. That's what I was saying. I think you were here for that part. What I was saying is, like, as developers, we're used to getting pretty generic requirements and being able to figure it out. With AI, you can't. You've got to get really deep. Like, I need to understand what, why, and how, so I can test this properly, right? Because you can't just like have someone have a QA person, or you can't send it to the business owner, right? Like, test it. Oh yeah, perfect, right? And you're done, because you can have the right answer now, and 10 minutes later it has a completely different answer. So you have to really be able to understand what makes an answer accurate. How important are those things that make it accurate, right? Because again, ours accuracy is 1,000, right? If you do anything, I don't care what you make better, if accuracy goes down one number, it's not going out, right? Think again, revert it, make some other change, because that's not going out. So for your application, who knows what that is, right? I'd say the average developer probably isn't writing that type of application today. Like, in 5 years, everything will have AI. It'll be so cheap and so good that you just won't. I look at it like, nobody used cloud computing 20 years ago. 10 years ago, if you told somebody to move to cloud computing, they would laugh at you because of all the custom stuff they've built, and ours is so much better. And now every company is scrambling to reduce costs and reduce overhead by moving it to the cloud. I see AI the same way, right? There's a lot of pushback. Our stuff is better, whatever it might be, right? And like, one of the things we actually thought with our application is we were going to save people time, and we didn't. What we did is we allowed them not to have to cheat and find little ways to do things faster that would create an accuracy. Because the humans were like, oh, this if I do this step by step every single time, it's going to take me 20 minutes. So I'm just going to find I'm going to have a little system that'll allow me to do it in 2. So it still takes them 2 minutes, but they don't, like, their little system that did it in 2 meant that they would miss stuff. They would not realize that, like, they're denying something that shouldn't be denied. So it didn't actually reduce the amount of time that people were spending. It just made them more accurate. Yeah.
So we're changing from, you're mentioning from legacy to AI, right? So we're going from a world of truths to a world of scale, right?
Right. Well, you're going from you're going from red-green to shades of red, yes, and shades of green.
From absolutes to variables. So you also mentioned there's drift as well, right, from AI, and you have your traces that you mentioned that you go ahead and follow those. Are those traces that you have, the small percentages out of all the requests, are those continually being systematically analyzed, or are you going back and having a human reviewing those ones as well to verify, or where? You
always have to have a human in the loop.
Sure.
I think we talked about it a little bit, right? Like, you can't just, today anyway, you always have to have a human in the loop, because, again, my experience with LLMs is sometimes they're right, sometimes they're wrong. They're more, you have to work really hard to get them more right than wrong. But then you have drift. right? Whether it's changing the model or for whatever reason. And again, like things can change, how well it responds can change without you changing anything, without any of the input changing, and without the version of the model you're pinned to changing, right? Just things that happen between your request and actually going to the model and getting the response change at your provider.
So the human aspect there is analyzing like the confusion of the AI response or something else.
So again, so we're grading. So what we have to find out is how accurate are our grades. So we're still having to go look at the responses and grade responses, but we're grading the responses to make sure that our grading is accurate. Right? That's where you want to be. Right? We're on our way there. We're not 100% there yet, because our grades aren't as accurate as we want them to be. But if you want to be able to, like, as developers, right, this whole nice thing about DevOps and CI/CD is like, boom, I make a change, it goes in, runs unit tests, nothing's broken. It goes out, goes to another environment, runs functional testing, I didn't break anything, right? Everything works just like I told it to. Boom, that can go out right now. Doesn't matter, won't affect customers, right? You need that with AI, right? If you have AI in your application, you've got to put that into your CI/CD chain, because now you'd be like, oh, I need to go run 1,000 tests to make sure it's giving the right answer before I go push it to production.
So where does the human involve? I mean, because I understand that the human needs to be. I'm trying just to understand, like, from a process
Right.
perspective, right? Are they like?
So from a process perspective, right, you can either manually test these results, right, run hundreds of them, go look at random samplings, right, like I said, and maybe your application, that's fine. My application, it takes me 10 minutes to grade one response. I have like 36 criteria, and I have to go look through documents, right? I'd be like, oh, here's this word. Yep, here's this paragraph. Yep, came exactly from there, exactly where it said it came from. Here's the section, the subsection, the clause, the subclause. Like, this is 100% accurate. I have to like look at all this stuff and verify it and go through documents, and like it is an arduous process to grade one, and I have to grade hundreds to have some level of comfortability that it's still working the way we expect.
And so are you like, you're queuing a deployment essentially, more or less, your deployment pipeline for like until a validation, and then like once you validate it, then it finally gets deployed, more or less?
So what we end up doing, right? So we're in transition currently. What we have is, we don't change prompts, we don't change models. All this stuff can change, but if you change a prompt or you change a model, it's a week.
Yeah, sure.
It's just going to take a week, because it's like, oh, here's a problem. Oh, let me fix that, right? Because it's like, oh, you can run integration tests locally. Yep, no problem. I run integration tests locally. Everything's fine. And when I push to production, it'll be exactly the same, right? Which means you have to run those tests locally against the same model externally. And very few developers are going to sit there and run them 1,000 times and look at every one of them. So creating some sort of automation, some level of a lot of that, it tends to be that after it goes to a pre-production environment, all the tests are running against it, and then it's like, oh, doesn't work. Now it's going to go back. So the manual process is, it goes up to QA, right? And you're like, okay, let's go, because we have this thing to bulk run. Go run me these 100, and I know what it should come out to. And I'm like, oh no, this has changed. This is wrong. But it takes me 10 minutes per, right? So it's 1,000 minutes to grade 100. And that's a lot.
In your process, when you notice that something is off, so what are the typical steps to improve the accuracy?
It's more often than not, it depends, right? If the change is because we change models, because sometimes we'll be like, oh, let's go look at this model and see if it's more efficient. And we'll do a lot of that testing locally before it gets into like a pre-production environment. But we're constantly like, oh, here's this new model that's supposed to be better. Because again, like our system is considerably more accurate than humans, like the humans that are doing the job, but it's not 100%. And the closer to 100%, the better our product is. And if we could just change a model and modify some prompts, let's go for that. Or if there's a new version that comes out, right? Because eventually, right, they're going to just deprecate the old one, so you've got to stay on top of, right? So even though we're using, GPT 4.0, It's GPT 4.0 2024 0904, and that's only going to be valid for 6 months. All right, because at some point you're going to be too behind, and they're just going to say we're getting rid of this one, move to the new ones. So we have to test for that type of stuff as well. So if we're making changes and they're specific to prompts, right, we're going to be testing that stuff locally, because we don't want to have to run through a whole application to get the answer, because that just takes like a minute and a half. So we have some tools to just kind of, okay, here's a known set of data. We've synthesized some claims that have expected results. Go run it against it, but then you've got to go evaluate that, did all the text come from the right place? Because when you deny, like in an insurance denial, right, there could be 5 correct answers on why that's denied. And sometimes it includes 5, and sometimes it includes 4, and sometimes it includes 2. So you've got to go check and make sure, like you can't memorize what it is. The other problem with memorizing what it is that it changes from policy to policy. And so you're like, yes, this is, because that's one probably ran into, like, yes, this is perfect language, but not for this policy. Yeah.
You mentioned some tools, so like obviously like regular end-to-end like Selenium, Playwright, WebDriver. Yep. Are there tools available now, or are you guys writing all these from scratch, basically?
So the tools are just, we have to come up with a prompt to grade the results of a prompt. Right. We have a single page app, so we can just query the endpoints directly that generate the results. And we also, so what we actually ended up creating is we have a tool that's similar to like what you would use for monitoring, like if you've got New Relic or Datadog or whatever, right? They're just, I'm going to sample, I'm going to take a certain number of these, I'm going to take all the information from the request, I'm going to go stick it in a database so you can go look at it. Or I'm going to grade it for how fast was it and were there errors, that type of stuff. We do the same thing. Customer by customer, we can set a percentage of the number of types of prompts that are run, and it will then put it into the scoring system and store the data it needs to verify, so that the scoring system goes, oh, I've got something else to score. And it just, again, it's the same prompts for the same grading for everything, so regardless of customer. So it just says, I've got something to grade, and it just goes and grades it. That's all stuff we've had to kind of handwrite, and every time we add a feature, we have to add more testing. Like it is, because we're like, oh, cool, we've got these 3 new letters that they want us to write that require us to do 3 different prompts, and now we've got to go figure out testing for those 3 different prompts. So, yeah.
Are you having to do like prompt chaining? I made up that. But
yes.
Is that essentially?
Yeah. So again, like we're not necessarily. So I'll say we'll make it an AI enhanced call. So we're not testing every prompt. We're testing every AI enhanced call, because how it does it, we don't care. Some of and that changes from time to time, right? So we had some stuff that was split up into 4 calls, and then a new model comes out where it only has to be 1 call. So it's faster and it's cheaper. Or it used to do RAG because the context wasn't large enough to hold in this entire document. But now this new model is actually faster and cheaper and better and can hold the whole document. Oh. So we've had to make those types of changes where when we grade, we're still just grading the output. How it got to the output doesn't matter. And at this point, we haven't fine-tuned it so much that we're just every request. Like we're going to, when we are tuning that, we may do that, like, oh, this is the piece that seems to be worse. Like we're not doing that overall because this is more functional testing, and that's where I've seen the most bang for the buck, right? Because at the end of the day, the customer only cares what they see. They don't care how you got there. They don't care if in your chain prompt 3 is a little off. They just know that, well, the overall result is crap and you need to fix that. Yeah. So that's where we're really focusing. Because there's right now there are the 2 separate camps, which is break everything out into tiny prompts and send them to tiny fast models and do as much asynchronous processing as you can. And the other one is use the newer, more complex reasoning models that can do the step-by-step and give it the step-by-step instructions that you would have broke those out. And so far for our stuff, neither works. So, because we tried that We tried both to solve our accuracy problem, and it turned out, it's really kind of weird. It turned out the entire problem is that you should not give a real world example. So if you have here's a tip from the trenches. If you have a question and the answer depends, do not put the question and answer as a few shot. Anyone know what a few shot is? Okay, few shots are examples, right? So it's like, you tell it like, oh, you're a super genius and you answer questions about things, right? And if, what time is it, is the question, you should not have it say, like, I need you to answer this way. Like the genie says it's 3 o'clock, right? But if someone says, what time is it? It's going to say the genie says 3 o'clock because you gave it the answer, right? It knows it's got a question and it's got an answer. It doesn't care what time it is, right? So that was actually one of our problems, is that we had a response in there that was valid, but not always. And so we just like changed it to something that could never be returned, and everything was fine. But you find that through testing. So seemingly innocuous things that you're trying to get it to return things, because again, you want to try and use some real world examples because it has to match the things it's looking at. Like the closer it is to what it's looking at, the better your results are going to be if you give it examples. But if you give it something that could be different from request to request, you can't actually use a real question and a real answer. Yeah.
Is there any type of like request authenticity to ensure that there's no cross request or any like information that might cross contaminate between requests or processing of requests?
Well, we're not doing a chat system where it keeps context. So like we do have multiple step stuff, and that stuff is just kind of held in the client, request to request.
I guess if I was like giving an encryption key in with a request, and I expect it
never give an encryption key with a request.
But you wanted to encrypt a response, so that way you can guarantee that what you sent in and what you delivered are actually authentic to the system, and the response is, so that way there's no potential interception or other type of
We're not doing anything that requires anything more than making sure that you're end-to-end TLS.
But I guess I'm trying to think if is there any type of reason where you would want another deeper level inside of that.
I mean, that's application specific, right? Like if you're worried about something being intercepted and somebody telling people to do things that they shouldn't be telling them to do, then that's, you may want to have, higher levels of stuff like that. But like we're business to business, and if you're going to come to our system and screw it up so that you get different stuff, that's fine, whatever.
I guess that's one of if I'm going to send a request, right, and there's a queuing system, right, what if the system happens just to grab the other queue, put it together, and start processing both at the same time?
Which is why you need to have continuous real-time monitoring. Because all of a sudden your answers are all wrong now. Like, so again, if they do something screwed up, we were talking about the OpenAI bug where they had a bug in their tokenization system that was screwing up the tokenization of your incoming request. It would turn into something that was gibberish. It would find a match for the thing that was gibberish and return it back in what it thought was real words. So it was getting an answer. Like the model was doing exactly what it was supposed to do. Something in front of it was jacked up. And for a day, everybody using ChatGPT got garbage. So like you need to have a way to, on the QA side, right now, that's something you have to think about. I have to monitor this thing and make sure that something's not getting screwed up along the way, whether it's our fault or their fault, so that the answers are coming back wrong, which is why my suggestion about siphon off a percentage real time and grade them in real time and have monitoring alerting, right? It's the same thing as, are you down? Nobody cares if you're up if you're wrong, right? So if you're just doing junk, nobody cares, and it's so much harder. Like I would say that like I don't do constant testing of applications that use kind of standard Boolean logic, right? If it's right or it's not, because the code didn't change. In AI, it could be wrong all of a sudden, and it's just something you have to kind of watch out for, because it's more likely to happen slowly and insidiously. You will get those things like every now and then, like, oh, everything's all broken. Also, make sure you have retries, because you'll get errors. Who here's subscribed to the OpenAI status page? It is constant and forever. So make sure you have retries built in. But again, it's those things like, you want to make sure that it's not so much like, I worked at a company called DataX where we basically we would consume other APIs and return a response. Right? You give us, is this fraud? Let me go check their bank account number. Let me go check the credit reporting database. Let me go check a bunch of different things. Right? Let me go check to see if this is, this person actually lives at one of these addresses. We could have problems downstream, and we would find that the errors were coming downstream, but it was either right or it was wrong. Right? They were either getting errors from them or nothing. Where on a model, you can get just different answers. Right? Nothing's changed, nothing's different. Your people are asking different questions. 'Cause again, you use them a little differently. Right? You don't have I have the exact standard input. No, it's ask me a question. That's the beauty of these things, right? Ask me a question. And, oh, cool, I'll take your question and give you an answer. If people are asking things differently, you may have terrible results, right? Or you have a new set of customers that are asking things differently, and it doesn't work for them, but it worked for everybody else. But overall, your application is crap now because 50% of your users are doing things differently and it doesn't work. AI is fun. I've worked with applications that were, model based, right? Machine learning models. And the things there were just more like how do you get it to run faster and, training it on larger data sets and keeping them up real time. But that was standard input in, standard input out. Or LLMs are throw me some text, bro. And sprinkle it with some stuff that tells me what to do.
Do you find yourself a little bit more reluctant on releasing features?
We are a little more reluctant on releasing changes to model versions and prompts. Again, we have humans that are constantly monitoring a certain percentage of customers, right? What we want to do is have less human monitoring, right? That doesn't scale, right? We're an early stage company, so looking at every single request that goes in and every single response that goes out, that it looks mostly okay. And most of the time it's again oh, let me tell you how to ask this, right? If you're as old as me, you remember you had to learn how to search for web pages, right? And depending on which search engine you were using, you asked for it different ways. But right now, search engines are good enough right now that you can probably much just ask it however you want, and it'll come up with something. You'll likely get a result in there somewhere. But if you really know what you're doing with searching, oh, I want to find this thing on this website, you can tell it to pin it to the site. AI is kind of the same thing. If you ask it right now, if you ask it certain ways, because it's a general AI, so it knows a little bit about a lot of things. And if you haven't gone through the painstaking task of getting a bunch of user input and a bunch of user output and done some fine tuning to make sure it's going to always work the way you want it to, if they ask it a little bit differently, they'll get a different answer. So you have to kind of guard against that and there's nothing you can do about it, right? There's things you can do about it, but you probably can't afford it. If you're early, you don't know what the questions are, right? Unless you have a bunch of money to go and synthesize the data, right? Again, one of the things that LLMs are using and the reason people are flocking to AI is because I don't have to have a data scientist and a data analyst spend months building up a data set so that I can build a model that might work, right? It works for the data set, but does it work in real life, right? Because the data changes over time. So we got this data set at this point in time, and now we're going to use it to run the model and come back with as accurate as we can get it, which takes usually months. And now you're at time plus 3 months where the data might be different. You don't have to do that, right? You can just ask it, give it some information, ask it a question, and tell it how to respond the right way. And a lot of times it just does it. Right? The first app I ever wrote was talking about the thing where it says, hey, I need to find out the contact information for the board of directors for a nonprofit. So I get the list of nonprofits from the IRS, and I feed it into my app. And my app queries Google, and it goes to the web pages and says, hey, does this look like the web page for this company? Yes, cool. Which one of the links will take me to contact, will help me find the contact information for the directors? And then it tells you when you click on that, and then you go to the next page. And you're like, okay, cool. Find me the stuff on here. It just took a little bit of prompting. I didn't have to train anything. That's these models are creating a place where you don't have to do a lot of the work. And the crazy part is my first try with the prompt worked. Never happened again, but the first try worked. And we deployed it, and it's been running for a year now without any changes, which you probably should have some changes, but people have to pay for changes. And sometimes they don't want to. But it probably works good enough. So, any other questions? Cool. All right. I appreciate if there. Oh, let me ask you some questions. Is there anything that I didn't talk about that you wanted to have me talk about, or is there anything that was just that was way too much and I don't care on sections? Because this is the first time I've actually given this talk to humans.
You give to AI before?
No, I just give it to myself. I don't consider myself a human. Much like my friend here, I am a computer. So, yeah.
As conference speakers, this is a type of feedback we're looking for. So.
Yeah, I have to get this presentation in Montreal in February, so I wanted to kind of.
Are those that available for us?
What's that?
I missed the beginning of the presentation because there was a truck stuck. A train stuck at the railroad.
Oh man, I hate that.
I know the one train.
My wife was kidnapped and tied to the railroad track. So I was late.
You sharing the slides with us?
I can.
I think it was very good for a general audience, but for technical, you didn't scratch nothing with machine learning. Was it?
Oh yeah, this is not the machine learning user group.
X-score, supervised versus unsupervised, none of that. There's
Right.
different metrics, parameters we look at on how good a model is trained. And I see a lot of people in my contracting job, there's machine learning people where if you don't know the lingo,
Right.
they got crappy models and they just been sitting there collecting a check. And they trained it a crappy model that doesn't really do much, and he's just selling it, and then people that don't know, and I'm like...
Well, that's because people aren't testing the results.
Yeah, and I'm checking, I'm like, some stats on your model, and they're like, that's when they get scared, and I'm like, oh, okay, so...
Yeah, and again, this was basically so that world, right, where you need to create your quadrants, and you start figuring out your false negatives and your false positives, true negatives, true positives, all that model jargon, right, that I had to... I did learn a bit of, right? I don't even need anymore. If I wanted to go build a model, or I wanted to go at some point, right? My assumption is that we'll be able to use models as a service to a certain point, but at some point to get it past, it does 80% on just prompt tuning and few shot, right? To get it past that is going to require fine tuning, which will get it some percentage farther, right? Maybe 90%, maybe 95%. And then it's just going to have to be, if you want it 100% accurate, you've got to go find a basic model, right? Because my specific case, right, I'm asking it to be basically a paralegal, right? I want you to evaluate this as a paralegal. How valid is this legal document and what this person is saying and what this person is doing? And go find the legal justification for denying an insurance claim, right? It can the wrong information can get past people, right? It just happens. So again, at the accuracy that we have, we are more accurate than most humans doing the job today. But I was having a discussion with our architect today. Is that and that'll be fine, right? Until they've been using it for a year and they don't remember how humans did it. And now they're just why are these 20% wrong? Not during a hurricane, right? 50% are wrong the first time, right? They've got to get sent back and sent back and sent back and redone, right? And these nope, that one's fine. That one's 80% of the time it's fine. They don't have to be redone. but they're going to forget that. Like, just like we're all like, what do you mean I can't, run a game at 120 frames per second with like full realistic graphics like 20 years ago, right? That was a pipe dream on science fiction movies. So, but today it's expected. Like, it's jaggy. There's some tear. What's wrong? I need a new card, right? So, my assumption, right, is that, we're going to have to evolve just because our customers are going to expect it. Like right now, we don't have a ton of competition. At some point, there's going to be competition, but and that'll probably also drive proprietary stuff, or if anybody can do what we're doing, right? Just to a certain extent, it's the proprietary stuff that'll differentiate. So at some point, I'm gonna have to do that. But most people today, like Josh's presentation, you don't need that, right? You just need to ask a model a question, right? You don't need to understand what went into it. You don't have to know linear algebra. You don't have to know pi data. You don't have to know Pyrite. You don't know all the tools that everybody uses to create massage data, build data sets, train models, fine-tune models, like determine what the algorithms are going to be, mess around and figure out how many invisible layers of the neural network are there going to be, right? None of that matters. You've got people who are been doing this and are just selling it for dirt cheap that anybody can use, and it can answer a lot of things pretty accurately most of the time. The problem is it's pretty accurately most of the time. And if your business needs more than pretty accurately most of the time, then like another step is putting in the if it's wrong, do it again, right? That's another the chain of thought one someone brought up. I can't remember who it was. Of the models is that a next iteration is, okay, here's the answer I got back from the model. Is it right? And if not, why? All right. Oh, cool. This is wrong because this thing. Okay. Now tell the model to give me a different answer, and here's the input from the other model of why it was wrong, so it does it right this time. So that's kind of like the next step in the evolution that we're working towards. But first, we have to be able to determine what's wrong. And that's the stuff that needs to be, again, all that stuff is great. But again, that becomes a significant change that creates a certain amount of concern, right? Like right now, for us to keep it accurate, we need 1,000 minutes for every change for a human to go grade it. And that's just enough to be comfortable. That's not enough to be sure. It's enough to be comfortable. If we need to be sure, you probably need 10 people grading it, right? Getting different perspectives on what could be right, what could be wrong type of stuff. Because we ended up doing that when we found one problem. We're like, okay, we need to go look at all these things. And then we had 10 people grading it and found some of the core issues that we were able to just kind of knock out. But it also required, okay, here are the options, here are the things that could fix it. We don't know if they fixed it or not, right? Because they look okay, but you didn't run it 1,000 times to see if it's right 999 times out of 1,000. So you've got to just run all this stuff and have people do all the testing. So it's you don't want to have to do that manually. It doesn't scale.
Yeah, and that's my feedback is, how do you gain confidence from this, right? And to me, it sounds like the biggest confidence is human interaction. Is the way to validate that, and without that, you're going to get drifts. At some point in time, you don't know when. So if you don't do that, you're really setting yourself up for a failure.
It depends. It depends on the type of validation you do. Like again, sometimes if you have something where you ask it a question, it gives back, whether it's going to give back tell me the mood. Here's the 5 options, right? Or you can create some internal test stuff of for the testing for our testing models, right, is I want an answer from 1 to 5, so we know on particular sets, right, should it be 1, should it be 5, should it be 3, right? So those are things that are static that we can test, but the stuff that we actually do is a lot more verbose, right? It's going to write a letter about why we're denying this claim. And there's a lot of stuff that goes into it. So again, grading the models it tends to be easier because you can have, again, you need a data set. You need to synthesize a data set. We were going through it for the stuff for validating the models. We first validated against human results, right? I had to go through and test all these freaking synthesized claims, and come back with a result. And we used someone pretty high up in the claims system at one of the insurance carriers we work with, to come up, because it's basically, okay, here's a report from a field adjuster, and here's their policy. Tell us, what should be denied, what items are denied, and what's the reason. And they farmed some of it out, and some of it was terrible, right? The item being, because it should be like, what's the item being denied? Flooring, baseboards, drywall, reason, flooding not covered, right? That's very good, item and reason. But then you get wind damage. Roof had wear and tear, right? Wind damage is not an item. The item is in the reason. Roof had wear and tear. And the actual reason is wear and tear. But that was a really good piece of synthesized data, because what does you do when you give it crap and it comes back with crap, right? Because when you give it really good reasons, it does really well. Because that's one of the things that I find that we were having problems with, is that we were really good, and we still are, really good at responding correctly when you word it well. But when you don't word it well, or you're an idiot, it does poorly. And so you actually need to synthesize poor data so that you can find when it's wrong. All right. So instead of like, oh, everything here is like a 4 and a 5, and it's accurate with a 4 and a 5, but how do the ones and the zeros go? Like, you want to see how the 2s and the 1s are, because that's what you want to catch. You want to catch things that are wrong. You don't want to be patting your back all day about how right it is.
So, have you ever experienced, like, I don't know, like a clash, like, okay, you have your context, right? You're trying to aid the user input, provide them a bunch of static context to feed to the model. But then you get user who watched a couple videos on prompt engineering, and he does some stuff and tries to set some context manually that may clash with your hard-coded context. Is that the experience? Is that anything that you adjust for?
What you're talking about are guardrails. So in your system prompt, right? So there's in your prompt for chat completion. Oh, come on, did it? That's way back there. I had a lot of slides. There you go. Right, you've got your system prompt, your context, and your user prompt. So your system prompt is where you're going to set guardrails.
I love it.
I love it too, man.
I was googling here about AI models, evaluating AI models.
All right.
Yeah, like I was ready into like the guardrails. All that. It's just
yeah, and so like our system, like if you want to come up with something stupid and write a letter that you can't send out, go right ahead. I don't care. Right? It's business to business. I'm not worried about someone's going to ask it how to make an atomic bomb. Right? Like, so the model manufacturers have to worry about that, right? So like you can't ask it how to make an atomic bomb. Show me a nude child, right? Like they have to worry about stuff like that. Huh?
More like the morals.
I don't. So we're business to business. And if you want to write a letter to a customer that has a picture of a naked child in it, well, that's your problem. Right? Like you're the idiot who wanted it and sent it out.
But it's just.
I'm not harboring child pornography. So I don't have it. I didn't give it to you. Right?
But then the model's not going to generate to begin with.
Right. I mean, that's an awful example, right? But what like we have found, like we don't have a lot of guard. We do have some guardrails, right? That here's the things that the legal team at the insurance company cares about. Here are guardrails, and we work really hard to make sure those guardrails are followed. But you can make it talk like a pirate, or you can have it sound like we had a demo. Someone's like, "Hey, can I make it talk like Shakespeare?" I was like, "I don't know. Let me see." And we put it in. What the item we're denying is the flooring, and the reason is flooding, and respond like you're in a Shakespeare play. And it did, which was interesting and funny. But like, again, like you're using this thing to perform a job, right? And so that's not something you can send out. So you paid for something that wasn't very useful to you.
Did it say to be denied or not to be denied? That is the question.
No, I did use forsooth, though, I think. Yes, for thine flooring, I denieth the request.
Any other feedback?
Good job.
Thanks. It definitely felt chunky.
Well, thank you, Ryan, for recording this. You rock, because I have to actually catch your talk because my son decided to think he's Messi in football this afternoon and didn't break his wrist, luckily, because we were x-raying it. But I shot over here straight after. I apologize for being late. I did bring pizza. It's downstairs. Hopefully it's still warm. Couple of things. One, of course, thank you, Ryan, for recording this and putting it up on your YouTube. You rock. Thank you to Corporate Co-working, obviously, for the space. This is one of their smaller rooms here that we have. Usually we're in the event space, but one of the paying customers was running over their time, and I said, it's fine. As long as I'm paying $0, I don't care where you put me. So thank you to them. If you need a day pass, just talk to Tony. You can go on their website and check that out. Thank you to Adam for this awesome talk. I appreciate it. January's topic, I think, is up in the air. So I don't know if we have one lined up. So I guess if anybody has one, we can all go downstairs, grab some food or whatever, and chit-chat a bit. But
So that you do something last time? Right?
Well, he gave us a few talks and recommended January, but then Josh went, what about December? And he was like, that's fine.
Well,
Yeah,
it's a
you-
little chunky. It's all this time now.
yeah, no, if you do want to do your other talk at some point, yeah, go for it. So okay. Well, two things. I have a 1 month Symphony Cast membership to give out, and I also have a 1 year JetBrains license. Is anybody interested in either of those? You want Symphony Cast? JetBrains? Okay, boom, claimed. Done. Okay, awesome. I think that's all the announcements I can think of, right, Cody? Yeah?
Oh, that's what you can think of.
Everybody should join Discord.
Join the Discord.
Discord.
Join the Discord. Yes. In fact, we put up a vote for which talk Adam should do. He's doing both of these at Kung Fu, right?
Yeah.
When is Kung Fu anyway?
I think it's the week after Valentine's Day.
In January? Oh, February? Okay. Cool. Nice. So, yeah. What's up?
Discord link on the meetup? I didn't know that.
Discord link is on the meetup page towards the bottom. There's an invite link. I'll double check that. I think I had an infinite time. I don't think it expired or anything. There. You know, it's funny. There.
We had one spam bot already, but our Autobot took it out.
Yeah. Autobots assemble. Yeah.
I meant a human.
Yeah. No, well, I'll tell you a story off camera about that here in a minute. But yes, thank you everybody for coming out. I appreciate you all. I know December, we got holidays coming around. And yeah, packed room. So I appreciate you guys coming out. You all rock. And we'll catch you in January. Thanks.